Hello everyone, welcome to this lesson. Today's topic is operations on sets. We all know the operations of addition and multiplication on two numbers to get a new number. Similarly, here we'll carry out the operations of union and intersection on two sets to get new sets. We can even find the difference between two sets. Let's start with the union of two sets. What is the union of two sets? The union of two sets A and B is the set of all the elements that belong to either A or B or both. It is denoted by a U between the two sets A and B, which means the union of A and B. Now don't confuse this U with the universal set you learned. This U between the two sets means the union of these two sets. We can express A union B in set builder form as X such that X belongs to A or X belongs to B. Now let's understand the union of two sets with the help of an example. So here we can see if A is equal to 0, 1, 2, 3 and B is equal to 2, 3, 4 and 5, then we can write A union B is equal to, we can write the elements of A 0, 1, 2, 3 and union, so you'll put the union sign, and then the elements of B, that is 2, 3, 4, 5. So now union means the elements that belong to either A or B. So this set will include the elements combined. So A union B will be 0, 1, 2, 3. Now here in this set 2 and 3 is again repeated. So we cannot, you know the rule that we cannot repeat the element in a set. So we are going to take it only once. So remaining elements will be 4 and 5. So the union of two sets A and B here will be 0, 1, 2, 3, 4 and 5. Clear? Now let's understand the intersection of two sets. What is intersection of two sets? The intersection of two sets A and B is the set of all the elements which belong to both A and B. Now can you see the difference here? There in the union, it is a set that of all the elements that belong to either A or B or both. Now here in the intersection of two sets, here set of all the elements which belong to both A and B. Means that element should be in A as well as in B. And we denote it using an inverted U between the two sets. And it is known as intersection. So A intersection B. Now we can also represent A intersection B in the set builder form, which will be X such that X belongs to A and X belongs to B. Now let's have a look at an example to understand the intersection of sets. So here we have again the same two sets. A has the elements 0, 1, 2, 3 and B has the elements 2, 3, 4 and 5. So here we have to find A intersection B, which will be equal to, first write the elements of A, that is 0, 1, 2 and 3. Put the intersection sign to the other set, that is B. Now put the elements 2, 3 4 and 5. Now what does intersection of two sets mean? The element which is common in both, you can say, which belong to both A and B in this case. So A intersection B will be equal to, now in these two elements, which elements you can see are common in both? 2 and 2 is common here, and 3 and 3 is common here, and no more element. So you can say the intersection of these two sets is 2 and 3. So the intersection A intersection B will be equal to 2 and 3. Disjoint sets. Two sets A and B are called disjoint sets if they have no elements in common. That is, if I say A intersection B is equal to 5, means nothing, an empty set. If I do A intersection B, then I will not get any element inside the set. It means there is nothing common. Let's understand this with the help of an example. So here you can see set A includes the elements 0, 1, 2, 3, and B includes the elements 4, 5, 6 and 7. Now if I try to find the intersection, let's see what happens. A intersection B. Intersection means the elements that are common in both. So here let's write the elements of A first, 2 and 3, and then the elements of B, that is 4, 5, 6 and 7. Now do we find any of the elements in A and B common? No, there are no elements that are common in both. It means A intersection B will result in an empty set, or we can say phi. And when A intersection B is equal to phi, we say they are disjoint sets. So A and B are disjoint sets. So when there is no element that is common between the two sets, they are said to be disjoint sets. Clear? Overlapping sets. Two sets A and B are called overlapping sets if they have at least one element in common. So here, to be an overlapping set, there has to be at least one element that is common. So here we can say if A intersection B is not equal to phi, then those two sets are overlapping sets. So let's take an example to understand this. So here A has the element 0, 1, 2, 3 and B has the elements 3, 4, 5 and 6. Let's try to find the intersection in these two sets. So A intersection B will be equal to, let's write down the elements 0, 1, 2, 3, intersection of the set B, that is 3, 4, 5, 6. So A intersection B will be, do we have any set, any element that is common between the two? Yes, we have 3 that is common between the two sets. So here A intersection B is 3. It means there is at least one element common. There could have been other elements that would be common as well, but for this example let's have here one element as common. So if there is at least one element common, that means A intersection B is not equal to 5, we can say. If this happens, so A and B are overlapping sets. Clear? Difference of two sets. Let A and B be two sets. The difference between A and B is the set of elements which belong to A but not to B. Means the elements that belong only to A and not to B. So when we find the difference between A and B, we'll just take into consideration the elements of A, and we denote it by A minus B. We can represent this in the set builder form as X such that X belongs to A and X does not belong to B. So here we have to take the elements that only belong to A. Let A be 0, 1, 2, 3 and B be equal to 2, 3, 4 and 5. Now if I find A minus B, means the elements of this set minus this set B, 2, 3, 4 and 5. So here we have to take into consideration the elements that only belong to A and not to B. So here A minus B will be such a set which includes the element that is only in A. So let's see, 0 is only in A and not in B, so we can write 0. Then 1 is only in A, so we can take 1. Next 2 is here, we cannot take 2 because 2 is here. Then 3, we cannot take 3 either because 3 is also there. So we can say that the elements of set A minus B will be 0 and 1. So this is the difference between A and B. Now what will happen if we take the difference between B and A? Let's see. The difference between B and A is the set of elements which belong to B but not to A. So here we'll take into consideration the elements that are only in B and not in A. So A minus B and B minus A are completely different. We denote it by B minus A. So we can write B minus A in set builder form as X such that X belongs to B and X does not belong to A. So elements which are only in B and not in A. So let's look at this example to understand. So here, taking the same set A and B, let's find B minus A. So B minus A will be equal to, first write the elements of B, that is 2, 3, 4 and 5 minus the elements of A, that is 0, 1, 2, 3. Now we have to take the elements that are only in B and not in A. So B minus A will be a set in which there are elements only of B that belong to B. So here let's see 2 is here, so we cannot take 2. 3 3 is here, we cannot take 3. 4 is not there, so we can take 4. Then 5 is not there, so we can take 5. So the set B minus A will be this, 4 and 5 as the elements, and A minus B will be 0, 1. So remember, A minus B and B minus A in term of sets is not the same. Clear? Complement of a set. Given the universal set, the complement of a set A is the set of those elements of universal set which are not elements of A. Now what is this complement of set A? We can say that complement of set A are the elements that are not in A and is present in the universal set. And we can denote the complement of a set A as A and an apostrophe on top, which means A complement. Now we can present A complement in the set builder form as well. So here we can say X such that X belongs to universal set and X does not belong to it. So mathematically we can express this as A complement is equal to universal set minus the set A. We can say difference between the universal set and set A to get the A complement. So let's understand this with the help of an example. So here universal set is equal to 0, 1, 2, 3, 4, 5 and 6, and set A includes the elements 1, 3 and 5. So let's find the complement of A. So A complement will be equal to the universal set minus set A, we can say. So what is the universal set? It is 0, 1, 2, 3, 4, 5, 6, isn't it? And minus A, that is 1, 3 and 5. Okay, so when we subtract or when we find the difference, it means what? Now we have to consider the elements that are only present in the universal set, or simply we can say the elements that are not present in A, that will be the set of A complement. So the elements of A complement will be 0 is not present here, so 0. Then 1 is present here, so we cannot take 1. 2 is not present, we can take 2. Then 3 is present, so we cannot take 3. Next 4 is not present there, so we can take. 5 is present there, so we cannot take 5. And then we have 6, and that's all. So excluding the elements of set A, so A complement will be 0, 2, 4, 6. I hope you got the idea.